Um, all right. Shh. Um, can I talk now? I don't like this group. I'm gonna break all you guys up because I cannot talk over you guys. All right. So for this particular situation that we're gonna start talking about, we already talked about mean value theorem and rules value theorem, and hopefully you guys homework you understand those stuff. Those are fairly easy, and the stuff that we have to deal with right now is fairly easy. So I'm gonna go through both three sections at once. So first of all, we need knowing that how do we know the function if f prime of x is equal to 0, we know that it's a critical number, right? Which is Aiden as a horizontal tangent in this case, which is most of you had to do that. Or dy dx equal to 0. Or dy dx equal to 0. Or it could be undefined as well, or undefined. Dy dx is equal to undefined, or undefined. So it's just different notation. So f prime of x equal to undefined. So those are critical numbers. So there are four situations. Well, I mean, there's two situations technically because you can denote as f prime of x of dy dx. But what happened when f prime of x is greater than 0? What's the original function? Original function is increasing. Thank you. F of x is increasing. Because for Aiden, that f prime of x is a slope. If f prime of x is positive, then it's going to go up. So slope is positive. Does that make sense? So it has to be increasing. So f prime of x is less than 0, then f of x is decreasing. Now, if f prime of x equal to 0, then that f of x is a constant. And those are basic things that we learned last year. Now, here's my first part of the test. Do you guys know what's the first derivative test? Do you guys remember what's the first derivative test? Nobody remember last year. I don't know if anybody remember here on this period. What's the first derivative test? Yeah, but
you take the top setting 0 and the bottom setting 0 and try to
yeah, but that's not first derivative test. What's first derivative test try to tell you? Yes.
Isn't it like where you take the critical points and you put them on the number line and then you like factor the whatever's left and then you plug in to find the increase?
Yes, I'm trying to say you guys both say the same thing, but why are you doing that? What is the first derivative test?
Oh, isn't it a check? It's like a max.
Oh, good job, Brendan.
No, that's the whole point.
I'm sorry, he's Asian, you're white, so he got priority. No, I'm just kidding.
We're all Asian.
So, no, you already did say that?
We're Asian.
You did? I didn't hear. I'm sorry.
No,
I
you're
apologize.
We're all Asian.
Oh yeah, you're all Asian. All right. So, first derivative test is tell you how to find, like how to justify. Remember last year we had to justify maximum and minimum. By the way, there is a second way to justify maximum minimum is what? There you go. The second derivative test is also tell you the maximum minimum, but at second different way. A lot of people think about second derivative test is tell you concave up or down. No. the second derivative test is using concave up or down to tell you where's the maximum, where's minimum. That's how you justify use second derivative test. Usually people don't do that. They usually do the first derivative test. So how do I justify? On AP exam, you're gonna justify it as if f prime of x change from negative to positive at C, then f as relative minimum at C comma f of C. Do you guys remember last year? You have to say f prime of x changing from positive to negative. Therefore, x equal to 2 is relative maximum. Something like that. You had to justify it on AP exam. Do you guys remember that? And same vice versa. If f prime of x change from positive to negative at C, then f as relative maximum at C comma f of C. Now, this is how you justify on AP exam. Now, sometimes AP exam also have a situation that is not a minimum or maximum. When does that happen?
That's true.
No.
What do you say?
No, there's sometimes it's not a relative minimum and not a relative maximum. Yes. Well, you can have critical number. You can have critical number. Yes. Jenny? No. Fiona?
Oh, that's really good.
Point of inflection.
Possibly, but not all the time. Yes.
Even if-
No. Yes, Almond.
even if, like, all this stuff.
No. Okay, I'm gonna write it down and see if it makes sense. If f prime of x is positive on both sides of C, right? If it's a positive and positive, see, I can go up and go up again, right? But it doesn't have to be this way. I can go up and up, right? That is not a that's not a maximum or minimum because you can go up and up. Or f prime of x is negative on both sides of C. Then it can go like, whatever. It can go down and down. Therefore, it's neither maximum or minimum. Right? You can go up and down and down. So such certain situations like this, and some people would say that's an inflection point. Yeah, but it doesn't have to be an inflection point. It could be go up this way, concave up, and then concave up again.
It's like when you-
Okay, so that's our first derivative test. Are we okay here? And then we have to do number line test. I will show you how to do number line test, Aiden, in a second. But we're gonna go to second derivative. So if f double prime of x is greater than 0, then f of x is what? Concave up. And the way to think about concave up is situation like this. Like any of those points is concave up. That's when the tangent line is always below the graph. And that's really essential for you to understand other situation. When the tangent line is below the graph. And that's why it's concave up. f double prime of x is less than 0, then f of x is concave down. So a concave down will be like this. So at this point is concave down because tangent line is above. Do you see that they are above? It's kind of like this. If tangent line is above, then it's concave down. Definition of point inflection. If f double prime of x changing from positive to negative or negative to positive at c, then c comma f of c is inflection point. Inflection point. And yeah, so that is point inflection. Lastly, what's the second derivative test? Do you guys remember second derivative test? How do you second derivative test tell you they are relative maximum and relative minimum? Why that is?
You combine it with the first derivative, so it's like positive in the first derivative test and also positive in the second derivative test, and it's like the absolute.
Okay, the second derivative test, the requirement is the f prime of c has to be 0. So it has to be a critical number first. But at that c, if f double prime of c is greater than 0, it means what? Concave up, right? So if it's concave up and is a horizontal tangent, so it has to be a minimum. Does that make sense? So c comma f of c is a relative minimum. F double prime of c is concave down and also horizontal tangent. Then the c comma f of c is relative max. So yeah. So that's pretty much the lesson for those 2 sections. Now we're gonna get to the 3rd section, which is harder. So because we're gonna go through all the stuff. And does that make sense so far? Aiden, I know it's very fast. Do you understand? Have you seen Karate Kid?
Yeah.
Let me see the first one. It's like the original old Mr. Miyagi one.
Yeah.
Okay. Mr. Miyagi, that's the guy. Okay. Do you remember the part that he's like paint the fence? He told him to watch the card, and he told him to paint the fence. And he didn't teach him anything. So I don't know if I can pull it up.
That was like the same, almost like couple pieces of mindset.
Huh?
Oh. Yeah. They're doing the same. Yeah, I was like, how did
We're here for our convertible.
How about an SUV?
All right.
Hey,
No sweat.
at fast
So,
you accomplish
He was painting the fence.
Hey,
McKenna. He was painting the fence, and Mr. Miyagi never taught him karate. He's getting body at school, and then basically that's the part
now look
that
me,
is
look
he told him
fence.
to
Hey,
paint the fence.
up, down, good. Bend the wrist, down stroke, good bend, see? Good, long stroke, up, down, very good. Ni ben
So he's actually secretly teaching stuff.
big
but
board,
he doesn't
right
know.
hand, small board.
And the part of he's finally learned how to fight
Oh,
is
satatat. Ush. That! 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 Show me sand or floor. Hat! Eight! 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 Hush. Yes! That! That!
so I guess
Beside.
so
Hat!
this is the part that we're talking about this.
Show me into
The paint offense last year. So basically, he threw a punch with this guy's MMA, so nobody messes with him. But he doesn't really do this stuff. He probably put you in chokehold. So if this is gonna be a concave down, the tension line is above, and it's concave down because f double prime is negative. This point has to be a maximum. Does that make sense? And if it's on the bottom, it's gonna be a tension line on the bottom, but it's concave up, so that point has to be a relative minimum. Does that make sense? Okay. So yeah, so that's it. And we're gonna go through a question. So right now we're gonna go through a question like this. We're gonna teach you how to graph using the first derivative and second derivative. Yes, your test is gonna be a full graphing question, have vertical asymptote, horizontal asymptote, has a all the things, but mostly pre-calc, and then the calculus part is just small part. So let's talk about what are those parts. So right now we are talking about the third sections. The third section is gonna be, okay, well, I'm gonna ask you in original function f of x. I'm sorry. F of x is gonna tell me a lot of information on f of x. Original function can tell you what is the x-intercept and what is the y-intercept. That's the original function. Original function can tell me the domain. Original function can tell me the symmetry, and this is what you learn in pre-calc. If your teacher actually go through all the things with you, it should have symmetry, domain, and range. And symmetry usually is tell from something called even or odd function. I don't know if you guys remember that. Okay. And an original function can tell vertical asymptote. I don't know if you guys remember how to find vertical asymptote is denominator equal to 0. We did that this year also. Horizontal asymptote. And that's what original function can tell me. Now this is all in pre-calc. If you pay attention, this is a pre-calculus. Pre-calculus. Okay, let's go to f prime of x. F prime of x, you can tell increasing versus decreasing. So which region is increasing, which region is decreasing. And you can tell with the maximum versus the minimum. F double prime of x can tell me that when it's concave up versus concave down. And this is gonna be inflection points. And we're gonna learn how to graph this with our calculator. Do you guys remember how to do that? Okay, so I hear you are gonna go look at original function. There is obviously no vertical horizontal asymptote because there is not rational function. Only when you have denominator, you will have a vertical asymptote or horizontal asymptote. So you don't have any of those issue, but you can start with x-intercept. How do I find x-intercept? Set y equal to 0. Then what do you do after that? Factor. So you can factor the x to the third and x minus 4. X equal to 0, x equal to 4. So that means 0, 0, and then 4, 0. I hate student told me that x equal to 4 is the x-intercept. No, x equal to 4 is a vertical line. The coordinate is your x-intercept, 4, 0, or 0, 0. How to find y-intercept? Well, y-intercept and x-intercept are the same in this case. X-intercept, y-intercept, and this is y-intercept as well because 0, 0 is y-intercept and x-intercept at the same time. So we know x-intercept and y-intercept. Do we know the domain? Negative infinity to infinity because it can equal to anything, so we know domain. Do we know the symmetries? How do we tell the symmetries? Yes.
Isn't your highest power?
No.
You flip x and y.
No.
What? Isn't that how you determine even?
Plug in what?
Oh yeah.
Plug in negative x. So you're gonna plug in negative x to the origin function. If you give it the original function, if you give it the same function as before, then that's called even. And if f of negative x equal to negative is opposite the original function, then it's called odd, which is even has symmetry to what? Y-axis, kind of like x squared. And this is symmetry to what? Origin. Okay, so symmetry to origin. Now you can have a neither. Neither is not the opposite or not the original. So in this case, it's actually negative x. This is negative x to the fourth minus 4x to the 3. That's equal to x to the 4 minus 4 times negative x to the third, which is x4 plus 4x third. Now, if you realize it's not opposite original function, it's not exactly the same as original function, so it's neither. So in this case, you will have neither odd or even. So obviously no symmetry. No symmetry is fine, no big deal. 99.99% of the function has no symmetry. So we got a symmetry done, we got vertical asymptote, we got horizontal asymptote. We're gonna do the whole original function. Am I doing okay? Now we're gonna go to the second. We're gonna go to the second function. We're gonna say f prime of x. So it'd be 4x cubed minus what? 12x squared. So here, Aiden, this is where the part is you have to do a number line test, which is we've done it before at the beginning of algebra test, but we never did it here. But we got a whole chapter you have to work with number line tests. So in this case, that if you factor out 4x squared, that's going to be x minus 3. That is going to be 0 and 3. And we're going to align this right here. Do you remember this at the algebra test? Well, this one is not an algebra test, but algebra test is pretty easy. It's plus, minus, plus. People just memorize it. But this case is not. Because it doesn't matter what you plug in the x squared. So you're going from negative infinity to infinity. You can plug in any number into 4x squared. It's always positive. Remember that? Anytime you have x squared, you could have negative 4x squared and everything is going to be negative. Now, if you plug in negative infinity to 0, so that's going to give you negative, negative, positive. So positive, negative, negative. Aiden, do you understand so far? If no, just tell me no. You remember this from algebra? Okay. So this is gonna be a decreasing. You can write it down on the bottom, decreasing on the bottom, increasing on the top. And with this part, this gonna tells you this is a relative. What? Relative what? Minimum. And remember on AP exam, you have to write down x equal to 3 is relative minimum because f prime of x changing from negative to positive. That's what you're gonna justify on AP exam to justify relative min. Jenny, are you tired? That's a big yarn. You know, I have rabbit and he young
You have
too.
a rabbit?
Yeah, rabbit young is kind of funny, and they stretch too. They go like,
I'm a rabbit.
you know what I'm talking about, Claire? All right. So, when you have x equal to 3, then I will plug in original function to find out that where exactly the maximum because I need to sketch the whole graph. So if I have a minimum here, then I need to plug in original function. So I'm gonna plug in 3 to the original function. So 4x cubed, I think 4x cubed or 4x? X to the 4th minus 4x cubed, right? So it'll be 3 to the 4th minus 4 times 3 to the 3rd. So that's 81 minus what? 108. So it's negative 27. So 3 negative 27 is going to be your relative min. Now I'm going to take a second derivative. This is the only part I'm doing calculus. All other part is our pre-calculus. Second derivative is going to be 12x to the squared minus 24x. And if you factor out 12x on both sides, it's going to be x minus 2. You have to do another number line test. Now, this is going to be from 0 to 2. And that's going to be from 12x, and x minus 2. And I'm going to do with negative, positive, positive. Minus 2 is going to give you negative, negative, positive. So it's positive, negative, positive. So it's up, down, up. So this is 0, 0 is inflection point because it's changing from positive to negative. And 2 comma, I think negative 16 is going to be inflection point. So this is the only part that you're doing calculus. Now for how many of you guys taking physics right now? Okay, so the original function is going to tell me the positions. The derivative is going to tell me what? Velocity function. And what is the third? Acceleration. So basically they are correlated. They are not like everything is all going to be the same. So SVA, what I will tell you, that you can also say, you know, which part is speeding up, do you remember? And which part is slowing down? Yeah. So this are all the Calc 1 questions. So there's so many things involved here, and it's gonna be the one that, you know, help you. So what happened is I'm gonna graph this. Am I using all the information? And first of all, I'll graph x-intercept. So I go in, graph the x-intercept. Is that okay? And I also point out the relative minimum. Where's the relative minimum? 327. So each one we're gonna do a, let's say it's this one's 10, this one's negative 20, and this one's negative 30. We change the scale by AB2 is a 10. So negative 27 is roughly right here. So if it's a relative minimum, you draw a smile face. If a maximum, you draw a sad face. So this is a chin Chin is facing up, so it's minimum. Where's the inflection point at? 0, 0. And so we put a cross here because every time we go through a cross, it's gonna be a concavity change. And at 2, I think 216, right?
Yes.
It's gonna be another cross. So there's 2 cross. So cross means inflection point. What you're gonna do is you're gonna go look at the first derivative. It says decreasing, decreasing, after 3 is increasing. So you kind of draw like a plan. This is the plan I'm gonna draw. So something like this, but this is not the actual graph. So this is just going to first derivative, it going decreasing to the 0, and then decreasing again, and then positive is increasing. And then what you're gonna do is you're gonna look at concavity. Before 0, it's gonna be concave up. And that's why it's concave up like this. Is that okay? After the cross, changing concavity. So that's why I draw a cross. After the cross, I'm changing concavity again. And that's gonna look like this. Okay, so we have homework. It will just give you 1 sheet instead of give you 2 sheets because I didn't want to give it both. I'm just gonna give you 1 sheet, but I need you guys help each other out to finish the first sheet of homework. Hopefully you can finish before we leave. We have what? How much time? 5 minutes.
Mr. Gay, the retake maximum minimum.
Yeah.
Building up in that feel tired building, and I am getting my video flashing like your photo, like I'm not just tired. Big building, yeah, it's all pretty cool. That was just great.
Oh, there, you should wear that. Should we wear go see her see
Oh, you're not. There's people from last year. Yeah, it's still in there.
Brother is still in it.
Yeah, he needs to be added to the BC group chat.
You know, my brother is still in that. Yeah, he is.
But the team is already so.
Oh, well, you know, you were in college. You died and then we were in college. Been there. I heard.
Our sister.
He's so cute.
Yeah, I agree. She got offered mission. I guess I somehow hit decline, and she's like, "Oh, don't you want the answer?" I was like, "Yeah, I do. Yeah, why did you hit decline by my airdrop?" I was like, "I didn't like to." No, I really like I don't have
Eva, Catherine, Aspen, Michelle, Sophia, on the. I don't. You know Colin Emerson? Sorry, Steve. From how white?
just now.
You look like a crazy.
Yeah, it's really cool.
It's weird because
I'm so excited. My dad was like, "Oh yeah, we're gonna go months ago," and then today in class, congratulations, because we got off and on. Hey, no, I'm on. Sometimes.
okay, but I don't think Prometheus got a
Ace,
license.
we pick it up, please. Yo, bro.
Well,
Let's go. My case is on.
but I don't know
Pick
who
up
Colin
the
Emerson
pace.
is. So we got it.
Yeah.
Good, how are you?
What?
Yes. Everyone gets top. Why did you sport? My son managed to be so good. All I work with you guys.
That's all. Yeah. So you see, it's original, right? So 10, white eggs. I'm fine. He's gonna have to do more than that to affect.
Get in the loop. No, you're right. But you're right. Oh, I need a table.
Yeah, we can play next week.
Yeah, me neither.
See my cards.
Baseball's more important than math.
Priorities aren't straight, right? I need to do it. My dad learned this, so yeah.
I only got this.
I thought you were saying.
You're getting the wrong side. So like 500 decades back.
Oh,
What did they go on? Why you go? Oh.
Maybe I wrote the.
I gotta do another tree.
I wasn't here.
Good one.
Dude, this is already.
Don't make out inside of them. Alright, let me start with something. If your piecewise function failed the vertical line test, that means something wrong with your piecewise function. So you draw a random straight line, that's why I teach you vertical line test. So anytime if, and that's my questions wrong, that's possible too, but most of the time the piecewise function, if you go scatter all the way to the left or right, you should only go to intersect one point at any given path. If you intersect 2 points on any given path, that means one of the restrictions off and you didn't do the piecewise function correctly. Okay, so go back and double check with each other. Check on that. How do you come up with a graph?
Roger. Oh. Oh.
You have to right?
Okay. Wait, no, Rob, you got it wrong. I got it wrong. You have to tell me shit. You're wrong. Oh. Don't come after your mother.
Minus this. Minus this.
Y equals negative 2. This is a negative plus. Negative 2 over negative 2. Not negative 2. Yeah. Look, you guys good job, Rocky. Should be negative 3 over 2. This kid wrote it like negative 3 over negative 2. And you get the correct negative. Oh. I don't know which I should copy this.
All right. Can you do an example proof by induction?